Hello and welcome back to the next project. In this project, we are going to use Microsoft Azure Cloud Services to use a data analysis step by step. We can see how we can use multiple services to get insights and information about a data using Microsoft Azure services, which are pretty relevant to our project. As you know, in Azure, there are a bunch of services, but based on the needs of your project, you need to focus on some of them. And it means for every single project, you don't need to use all services. In my channel, I will upload the project every week and use some of those services that are more relevant to data analysis and data science. So let's get started this project. As you can see on my screen, there is an architecture. Before doing any data science project, we need to have architecture. Architecture means what is the workflow in our project, in which step what we are going to do, and what is the output, and that output is going to go to which section. This is the architecture for our project. We have 3 steps: data ingestion, data transformation, and data analysis. In data ingestion, first we get data from the GitHub or any other public resources. In this specific project, I'm going to use GitHub for the repository to grab the data from the GitHub. After getting that data from GitHub, I'm going to use ADF or Azure Data Factory service to load this data to the data lake. So far, we grab the data from the GitHub, use Azure Data Factory, and load or push the data into the data lake. Now it's time to transform the data or do any data cleaning or data pre-processing on data. This is where Databricks come to play. Databricks is a platform which is not included in the Azure, but it is the third party with the Microsoft Azure. And we can take advantage of the Databricks because in this step, we use PySpark to transform the data. PySpark is the combination of Python and Spark cluster, and it is super fast. We use Databricks, and after that, based on the key vault, we can make a connection between Databricks and the data lake. As I said, just because the Databricks is outside of the Microsoft Azure services, we use key vault to make connection between Azure and Databricks. Now the transform data is in the data lake, and it's time to use another Azure services, which is called Azure Synapse Analytics. We use Azure Synapse Analytics and run some SQL queries inside the Azure Synapse Analytics and get insights for manager. This journey is wonderful and we want to go step by step. Now let's see the process and the steps that we are going to do. As I said, in the first step, we just overview about the data in the GitHub repository. After that, we go to the Microsoft Azure, we create resource group. And then we create a storage account or data lake. Then we should create data factory, ADF, and we create containers or folders in the data lake. Next, we have to go to the data factory services. We can get and set raw data into the data lake or push or pull the data. Now, we have to go again to the Microsoft Azure to create Databricks account. And we should create app registration to make a connection between Databricks and data lake. Now it's time to go to the Databricks environment. We create compute, or we should create a Spark cluster. And after that, it's time to transform raw data based on a PySpark. After that, when the data is ready, we can push the data to the data lake. And then it's time to create Azure Synapse Analytics. When we create Azure Synapse Analytics, we should create a lakehouse. Lakehouse is a SQL serverless. I will explain it later. Then we should load the transform data into the Synapse. And then we should create schema or view for the tables, as you know, for SQL. And then it's time to analyze data based on some SQL queries. So now we can start this project. Okay, the first step is getting more familiar with the data. We have two different data sets for this project. First of all, let me explain the project. The project is the England Premier Football League. We have two data sets for England Premier Football League. One data set is about the matches or all the matches during the season, and another data set is about the players. First of all, let me explain the matches data set. We have the date when the match was held, how many people attended to the match, what was the name for the home team, what was the name of the away team, who was the referee, in which week of the whole season that match was held, how many goals the home team could score, what about the away team. So this is the total, just the summation of these two columns, and every single other column that you can open this CSV file and see the columns. If you want to find this CSV file, just see the link in the description of this video. You can go to my GitHub directly and find this CSV file. This is the matches CSV. Now we can see another dataset. Another dataset is about the players. We have full name of the player. What is the age for the player, the birthday, the position, in which area of the field the player is playing, what is the current club for that player, how many minutes the player played, what is the nationality, how many times the player appeared during the season, how many goals he could have scored, how many assists, how many penalty he could get, and how many penalty missed, how many clean sheet. Definitely clean sheet is only for goalkeepers, how many yellow cards and red cards. Again, you can find this CSV in the link. Based on our steps, now it's time to go to the Azure and create resource group. You only need to go to the Azure environment. I just logged in with my account. You can create an account in Azure environment. There are a bunch of videos. I just put one of the best link. You can take advantage of that link and see how you can create Azure account. When you log into the Azure account, you might see different appearance. Just because I customize this dashboard for myself. You can design your dashboard based on your taste. I just put all the services that I usually use. I put Data Factory, SQL databases, Azure Cosmos, Databricks, Fabric, Power BI, Machine Learning, and Synapse Analytics. But now the first step is create resource group. Resource group is very important because every single task that you are going to do in the Azure universe, you need to have a resource group. All the services are mapped to the resource group and they are using the resources. Definitely, as much as you're going to pay to the Microsoft, you can have much faster and much more robust resources. For making the resource group, I can go to the resource based on a dashboard that I created, or you only need to go to this section and just write it down, resource group. When we go to the resource group, the only thing is that just click on a create here or create there. I click create. Now it's time to create a resource group. First of all, I should say what is the subscription. My subscription is Azure subscription. When you create an Azure account, you can have your Azure subscription. The resource group, I'm gonna call, for example, England Soccer Resource Group. You can call whatever you want, but just Microsoft lets you know this naming is acceptable or not. Fortunately, it is acceptable. Now you have to choose the region. Based on your location, you can choose one of these options. Definitely, when you choose the nearest data center for the Microsoft to yourself, you can have much faster sources. I used East USA. Now we can go to the next step. The next step is just a tag. These steps are pretty important for IT teams, data engineer teams, but not for data scientists and data analysis, because we are going to work with this data. We are going to build a model. We are going to analyze the data, not just about the connection and just configuration, but it is good for you to know it. Now we can just review. This is our subscription, and this is the name of the resource group, and this is the region. The last step is just create this resource group, and we need to just wait. If I go to the resource group, now resource group is ready, and you can see the resource group is 1, and it means if I go there, I can see my resource group. If I click on that, this is my resource group, and now I am able to assign any services like Data Factory, Databricks, Synapse, Data Lake, and any other services to this resource group. This was the first step. Based on the steps, now it's time to create another services in the Microsoft Azure environment, which is called ADF or Azure Data Factory. So far, if I refresh my dashboard, we just have one resources as an England storage. The next thing is Data Factory. I can search Data Factory here, or I can click on this to go to the Data Factory. I go to the Data Factory to create a new Data Factory. I can go to here, and again, the subscription is my default subscription. The resource group, the England Soccer resource group. The name of the Data Factory, we can call England Soccer ADF or Azure Data Factory. Microsoft allows us the region and the version. That's okay. We can go to the next. That's okay. Nothing about networking, advanced setting, tags, and just a review, which is very simple. Just review the information, the Data Factory, and that's okay. Just create the Data Factory, and again, the process is undergoing. We should wait. Yes, there is Data Factory. If I go to the dashboard, just refresh. The Data Factory is here, and we can just go to the Data Factory. This is the Data Factory. If you want to see the environment for the Data Factory, you should click on that, because Data Factory is a studio. As you can see, it means it is mapped to the Azure, but not in this window. You will redirect to the another places. So if I click on the Launch Studio, we will redirect to the Azure Data Factory. And this is the place that we are going to work with Azure Data Factory. This is the England Soccer ADF that we called it. And there are a bunch of steps here for making the pipeline, anything, monitoring, manage. And we will talk about all of these ones later in the project. We are just creating the resources right now. Now it's time to create a place for the data or data lake. We need to have a place to push the GitHub data inside it. And after that, we can pull the data to the Databricks. We can transform it and again push it to the data lake, again pull it and use it in the Synapse. We need a place, and this place is called storage or blob storage or data lake. There is a difference between the data lake and a storage, and I will explain to you. For creating a storage account, you can go to the resource account or you can click on the resources here. I go there and I click here to the services and I just run storage. If I go to the storage account, I have nothing and I should create. Again, I can create on a create storage account or create from here. The first step is I should say what is my Azure subscription. This is default. I use that one. What is the resource group? What resources we are going to assign the storage to? We are going to assign storage account or data lake to this resource group that we made it. And now we have to say what is the name for these resources. We can say, for example, England, soccer, let's say storage. Let's see, Microsoft. Okay, Microsoft allows. Now, again, the region is East US. What is the primary services? The primary services, Microsoft gives us three options. The blob storage or data lake storage Gen 2, which is the latest version for data lake in the Microsoft Azure universe, Azure Files, and other, or just tables. Just because we might have different data and we want to have hierarchical version as a folder, subfolder, anything in the project, we use Azure Blob Storage or Azure Data Lake Storage Gen 2 or the second generation. I selected the performance. If you are going to have just for the general purposes, you can choose a standard, or if you want to pay more money to the Microsoft, or based on the importance of the project, you can choose premium. I choose a standard just because this is just a project and we don't need to have low latency in the project. I don't choose premium. If you're going to work on a real project and based on importance of the project, definitely low latency can satisfy your customer much more. So I choose a standard. The redundancy, again, if you want to have the redundancy for your table, if you want to have the backup and how much that backup is important for you, you can use geo-redundant storage. It means your data can be stored in the different places around the world based on Microsoft data centers or just the locally redundant. Again, based on importance of the project, if you have very important project, definitely having different backup storage around the world in the different data centers might be the safer solution. But I choose LRS or the locally redundant storage. The next step, we don't touch anything about the security. Again, these are something that are very important for data engineers and network teams. The most important one is that enable hierarchical namespace. It means when we checked it, we are making data lake. If I uncheck it, we are just making blob storage. Blob storage, you can consider blob storage as a place that there is no any organization. You can create everything and push the data inside it. It might be very messy, but it has its own merits and benefits based on a project. But if you want to have folders, subfolders, and hierarchical structure, definitely you need data lake. And I checked it to have the data lake. The next step is about the protocol and the network things. We don't touch it. Access tier. This is, again, if you want to have very fast services, you want to choose hot, because in that case, the usage is very fast and you can answer every single request that are coming to your server very fast. Or you can cool it, or cold is the lowest one. We put the hot, that's okay. You can put any of these things that you wanted. We can go to the next. Again, these are all about the networking. Don't touch it. And in the most cases, as a data scientist, you don't need to create a storage account. It is very rare because all of them are set by the network teams or data engineers. You only need to work with the services. But we have to do it because nobody is here to make it for us. We have to make it, and after that, we can use it as a data scientist. We can go to the next version. And again, these are the protection, these are encryption, tag, and we only need to review everything. Okay, we are making the hierarchical version, SFT disabled, that's okay, we don't have any secure data. And encryption, I just checked the encryption here. Yes, that's okay. Now we can go and create data lake. Now data lake, as you can see, this is under deployment. If I click on the notification, you can see deployment is in progress, mapped to the England Soccer resource group. So we should wait till data lake is created. Now data lake is created. The only thing is that we can go to the resources, and this is the data lake that we have it. We have every single step we can that we set it before, and even if you want it, you can change or edit these settings. There are a bunch of things in the menu here, but the most important one is just access control and just the data storage. That we will talk about all of these ones. Now it's time to come back to the Azure Data Lake because we need to create some containers or folders to push the data inside it. So I go to all the resources or just simply click on a storage account. I go to the storage, and in this storage there is a place as a data storage. I click on that and go to the container. So far, there is nothing here because we just made it. If you want to create a folder, you can just simply click on a container. And just because it is a data lake, you can have hierarchical structure for your folders. I click on a container and I call it the first one as a raw because we want to push the raw data from GitHub inside this place. Okay, should be lowercase, that's okay. And that's it, just create it. And the next one, I create transformed because after a transformation process in the Databricks with PySpark, we want to push the data to the data lake inside this folder. And I create it. Now, inside these ones, we have nothing. Go to the container, nothing inside the raw data, nothing inside the transform data. We want to use Azure Data Factory and Databricks to push and pull the data inside the data lake. Now that everything is ready, we should push the data from the GitHub to the data lake. First, we should go to the GitHub. I go to the GitHub. We have two data sets. We have players and we have matches. We need to use Azure Data Factory for this process. So I go to the Azure Data Factory. As you can see here, we have ingest, orchestrate, transform data, or configure SSIS. I go to the author because I'm going to create a pipeline for this process. I create on the pipeline and we can create new pipeline. You can just close it to have more space here. Let's call this pipeline as a data ingestion. And the first step is that we should select the activity, which sort of activity that we want to do. We want to copy the data. We grab it and put it here. And the first step is name for this box. The first one, I'm going to ingest players data. So I call copy player raw data. This is the name that I'm going to call this activity. There are two important steps here. The first one is source, and the second one is sync. Source means get the data, and sync means, okay, we should say data factory. You get the data from the source, but push or sync or set this data to data lake. This is all things that pipeline is going to do. First, let's talk about the source. Data Factory should know where it can get data from. I go to the source dataset, and I should say the new data sources. The data source that we have is for GitHub. And just because GitHub is the external or public area, I cannot select Amazon SQL databases or even Microsoft SQL databases or any other resources just because it is outside of the Azure environment and it is the public, just called simply HTTP. You can select it, and what is the format of the file? You can see format of the file is CSV. So here we should select delimited text or CSV. I select it. Now we have to call this step or these properties. I can call get raw player. And we need to create link services. If I open it, there is nothing here because I need to create a link. This is just a name. And where the data factory can get data from. I call it, for example, get raw player just linked service. The description, nothing. The base URL. What is the base URL? The base URL, I'm going to grab players. The base URL is not this one. The base URL, I only need to click on a raw, and this is all raw data for all players. I only need to copy this link, come back to the data factory and paste it here. That's it. The second step is server certification validation. We put enable, that's okay. But authentication type, just because we are not pulling data from the database, this is a public area, so we don't need any authentication type. This is the public and general data. We put anonymous. And we can test the connection to make sure whether Azure Data Factory can realize the data source or not. And you can see the test connection tells us that this process is successful, and we can create it. Now we have the name of the properties and the link is set. Never mind about relative URL, it is for each process. Most of the time, the data engineers are working with this one. For example, here we just have two data sets. If we have 100 or many data sets, we cannot do this process manually. Data engineers just do this process for one of them, and after that, they can create iteration or for each process and just set one base URL and dynamic or parameterized relative URL. And in that case, they can grab the data just once. But just because in this project we just have two, that's okay. And for the header, definitely we need the header because data, as you can see, data is a CSV. And the first row, it should be header. So we check header, and just because we don't have any schema, we set none, and that's okay. Now we have data set here, and Data Factory know where data is coming from. And if you want, you can click on a preview data to see just the preview for this data. This is the data set, just a sample rows. It's not the whole rows, and based on these link services. But Data Factory needs to know where it should push data to. So we need to go to the sink, and we have to do this process again. So again, I should create on a new. If I open it, we see one data set, but it is the get data. But in this step, we need to set the data. So I create on a new, again, where we want to pull data to. We are not going to pull the data in HTTP. We are not going to pull the data to Azure database, where definitely we should go for data lake. This is the where that we are going to push data to. We are going to push data into the data lake or storage Gen 2 or Gen 2 Azure Data Lake Storage. So I click it. Which format we want to save the data? We want to save the data as a CSV format. So I click on continue. Again, we should call set raw players. In this time, we don't use get, we use set. I just copy. Again, we need to have the link services. I call the link services just linked services. Now we need to have account key because we need to make a connection between the data factory and data lake. We use account key. That's okay. This is our account in the Azure. The subscription is my Azure subscription. What is storage name? Storage name is England storage account, that you can see here exactly. And we only need to test the connection. The connection is successful, and now there is a connection between ADF and data lake. We need to create this link. Now we have set the data, we have the link to services, but Data Factory is asking, okay, in data lake, where I should set the data to? We need to set this data in the container raw data. We don't need to load or grab the raw data from GitHub and store in the transform. Transform data is later in this project, and we are going to push the transform data with PySpark and Databricks inside it. But we need to select the raw data. So I go here and select from a specific path, and this is raw data. Just OK, and raw data. What is the name of the file? We want to save as a players.csv. Just raw data. Inside the raw data, we don't need to create any folder. If you want, you can create a folder. Just because you have the data lake, you can have hierarchical version, but I don't need it. And we don't have any schema. Just put as a none, and we need as a header. And just OK. Now we have source data, we have sink data. We can run this process, but it is just for player. What about matches? We can do this process from the scratch. Again, I do it very fast because the process is the same. Now we have player and we have matches. We should make a connection between these two activities inside the pipeline. We have to say, okay, Data Factory, please first copy the raw data for player, and if it is successful when you complete it, just go for the next step, which is copy the data for the matches. When we said it is completion, go to the next step. Now it's time to run it, but before running any pipeline, we need to validate the process to make sure we don't have any error or issue. Unfortunately, we don't have any error. Before running the process, if I go to the raw data, there is nothing here. But we can push the data from the GitHub inside the raw data with just this process, debug. I run this process and it takes time. You can see it is queued. This process, the duration, the latency, it is exactly based on a storage account, based on a resource group that we made it. if you pay more, definitely you will save your time and you have much faster services. You can see the copy data for the player is done and it is succeeded. And Data Factory is working for matches to get the data from the GitHub and set it to the data lake. We can wait and both of them are done. Just click on the details to see. For this ID from the HTTP, the process is done on 47 kilobytes and all of them from the HTTP passed to the data lake. And this process is done with some specific information that are useful for IT team and network team. And we have the same event for this process, 55 kilobytes, and all 55 kilobytes are stored here. Now, if I go to the storage account, just refresh it, and if we go to the raw data, we can see all these two data. We have a player and we have matches. The matches name is not good because when I wanted to push the data, I forgot to put the name. So I can remove it, just delete it, and go here, editing. Here I can say matches.csv. And now if I publish all, that's okay. Now I can close it and we can validate the process. Then we can debug this process. Now the process is done. If we go to the storage account, just refresh, go to the raw data. Now we have player and we have matches. If I click on that, there is some information. In the next step, we are going to use Databricks and PySpark to transform these data. Before going to the Databricks, we need to create Databricks service in the Azure. Even though Databricks is outside of the Azure environment, they are linked to each other. So we have resource group in the Azure, and we should set and create the Databricks services in the Azure environment and then go to the Databricks. Databricks has its own studio like Data Factory or even Synapse, and we need to create it. I can search the Databricks here, or I can go to all resources here. I can select Databricks, Azure Databricks. I need to create a Databricks, so I click on it. What is the resource group? Again, the resource group is England Cycle Resource Group. The workspace name, we should set a workspace for these projects that we are going to have. For example, I can say England Cycle Databricks. I think we cannot have the space. That's okay. Yes, that's okay. England Cycle Databricks. And it is the region. Which region we want to have. This is East US. And it is, you can have the standard PySpark or premium or trial. I put premium, and you can do it based on your account. And even if you have the free account for Azure, you have $200 credit, and you can use that credit. You can use any services just because you have the credit. And we should set the manage resource group. I can say, for example, England Cycle Databricks resource group. That's a very weird naming, but I put it as a resource group. That's okay. And we can just review and create it. We have the workspace, we have the subscription, the resource group, and manage resource group is the Databricks resource group. And that's it, just create it. And you need to wait till deployment is done. Creating the Databricks account takes a time. It is much slower the process is much slower than other services just because it is outside of the Azure environment. But again, it is just dependent on your resource group when you wanted to create the resource group. When you choose the more strong services, you pay more, and definitely you have low latency. Now, Databricks is done and it is created. Okay, if I go to the dashboard, we have Databricks. And we can go to the Databricks to see this environment, but we should do one important step before doing that. Just because Databricks is outside of the Azure, we should make a connection between Databricks and Azure environment. Because why we want to use Databricks? We want to use PySpark in the Databricks to transform the data and again push the data into the data lake. So it means the connection should be between the Databricks and Blobs and data lake. So we should create the app in Azure environment. First, I go here and write Entra to create the app. In the Entra, there is a place as app registration. I go to the app registration and I just close it, simply click on a new registration. First, call this one as an England soccer app. That's it, and just register. Now we have one app, and later we use this app to make connection between the Databricks and data lake, because there are some credentials, there are some ID and code, and later in the Databricks we use all this code. But just make sure we should save the application ID somewhere, object ID, directory, tenant ID, and all the information. So I need to copy this information somewhere. I need to copy an application ID and open the OneNote or just a note to have it. Okay, I bring the note here. And the first one is called application ID. It is here. And the code, later we use this code. Then we have object ID. The object ID is this code and directory or tenant ID. This is the information for the app. And copy. Now we create the app, but we should create a certificate to assign a role to this application. It means we have Databricks, we have data lake, we have one application and one certificate or a rule to play a rule between these two environments. So I go to the certificate and secrets and create a new client secret. I call it as England just certificate. That's it, and expire after 6 months. That's okay. Just add it. We have again two information here. We have value and secret ID. Copy the value, go to the note, and write it down. Value, and we have secret ID. Secret ID. This is all the information that we are going to use it in the Databricks. Okay, now it's time to create that role. I go to the dashboard, go to the storage account or data lake, because we create the app, but we should go to the data lake and create a role in the data lake, because we are going to map Databricks to the data lake. Go to the access control or IAM. Before we worked in container, but now it's time to go to this menu and I should create a role. Click on add and add role assignment. There are a bunch of roles here, but the ones that they needed, it is a blob storage contributor. I click on that, go to the next. Now it's time to select a member who is going to have this role in the data lake. I select the role, and this is my account. This is a Fabric account. This is my current account in Azure, but I need to select England Soccer app. This is the application that we made it before. So I select it and just select the object that is there and just review and assign. That's it, just assign the app. Now, if I go to the role assignment, you can see we have England Soccer application, and the role is storage blob data contributor. Now, everything is okay to make a connection between Databricks and data lake. So far, all these processes are related to data engineering. But for a data analyst and data scientist, it is good to know all these processes. But later, it's time for us to run Synapse Analytics, run PySpark, clean the data, and all the configurations are done. We can go to the Databricks and run PySpark, and after that, go to the Synapse and run some SQL queries. Okay, for going to the Databricks, I need to go to my dashboard or click on the Databricks, or here, I click on here, and the Databricks is here. We can launch Workspace. I launch Databricks Studio, and we are going to the Databricks environment. Inside the Databricks, you can see this is totally different environment. The first thing is create a compute. Compute means we are going to use PySpark, but PySpark cluster needs a computation, and we should make a compute to all these steps for PySpark for us. So I go for compute, but as you can see, there are other things. For example, data engineers tool, even machine learning tools. We will talk about all these processes in the next projects that we're going to talk about machine learning. And SQL, anything, but we need to go to the compute and create a compute. There are a bunch of information here based on the resource group, based on the money that you want to pay. You can choose, and even based on your project. If your project is very important, the speed, low latency are crucial for you, you should use more memory or more cores. Or if your project is just a simple project, you can use FU, just a cores or RAM. For the policy, I put unrestricted because we don't need to set any policy in the cluster. I go for single node because I don't want to pay so much money. For the access mode, I've put single user, and this is my name. And you can set based on your name, definitely. For the performance, I'm going to choose the default. Just Scala version is 2.12 and Spark is 3.5. This is the last version for Spark. For the node, there are a bunch of different nodes and purposes. I'm going to go to just general, set 14 gigabyte memory and just 4 cores. Don't forget, if you create more memory, like 56 gigabyte memory with 10 or 12 cores, it takes too much time to create the compute for you. But for my project, I just say 14 gigabyte memory, that's enough for me with 4 cores. And I don't need to change it. Just review, we have unrestricted, single users, and the runtime is Scala and Spark, and this is standard DS3, and just create the compute. As I said, it takes time to create this compute. Now the cluster is ready, and if I go to the compute, you can see a cluster which the name is Mehrdad, and it is ready with this configuration. 14 gigabyte memory, 4 cores CPU, and other information. Okay, now that we make a compute, it's time to make a connection between the data lake and the Databricks. We need to go to the workspace. In the workspace, we can create a folder. I create a folder as England Soccer. And inside this folder, I'm going to create a note. or the Python node or PySpark. I create the notebook. This is the notebook that we are going to run Python inside the Databricks. I call this notebook as a transformation. Okay, the first step is going to make the connection. I just call it as a markdown. Let's call it as a access to data lake. And just run it. Let's have a this way to have a header. For access to the data lake, Microsoft provides us with a code. This is the code for making the connection between Spark Databricks and data lake. I copy it and paste it here. Okay, there is something here that we should set our desired configuration on it. Okay, if I open this node, I'm going to copy all of these ones and just paste it here. Later, we are going to use all this code. Okay. The first thing is that the storage account name. What is the storage account for our project? If you remember, the storage account was ink soccer storage. I just copy this storage account and paste or replace to this storage account here, here, in this place, and finally here. So I paste it here as a storage account, and here the next one is here, the next step, and finally storage account in this place. The next step is putting the application ID. We need to set application ID, service credential, and directory ID. First, let's go with application ID. The application ID, if you remember, when we create the application to make a connection between Databricks and Data Lake, we have the application ID. I copy this application ID, go here and paste as application ID. What is the directory ID? The directory ID is exactly your tenant ID. I copy the directory ID and paste it here. And the last thing is service credential. In the data lake, we create a role and we assigned that application to that role. And the value here is the secret credential ID. Just and paste it. That's it. If I remove all these things, okay, now we need to run it to make sure the connection is set. I just run it. That's okay. Automation, automatic compute is done. We need to wait based on the resource for Spark or any compute configuration. It might take time. Now it's done, the connection is done. We should check whether we can pull the data from data lake to PySpark or not, because we just set the configuration. We are not sure we can pull the data or not. For doing that one, we can go to the data lake that we grab those two raw data sets that we used with Data Factory to store from the GitHub. Okay, now we should load the data. We have two data sets, and here I'm going to load both of them. I'm going to pull the data from data lake to the Databricks. I create one code and I call it as pull players data. I create a new data frame as a df player, and I'm going to say the format of the file is CSV. The option, it should have header because this is a CSV file, and this is a load, never mind load so far. I need one more option just for infer schema. Infer schema means just because If you remember when we wanted to get the data with ADF or Data Factory from GitHub, we said we don't have any schema. And if we don't have any schema in Databricks, we cannot work with this data. But here we ask Databricks to create the inferential schema or temporary schema for this data set. After that, we can use this data. So we say infer schema to true. The next step is put the load or the location of the file. For location of the file, I remove it because this is just the default, and I put piece of code. There are three things here that we need to fit. The first one is, what is the name of the data lake? The name of the data lake, it is here that we set it. I just copy and paste here. After that, in which folder the raw data is stored. If you remember, in raw folder, we store the data. And what is the name of the file? We stored players in players CSV. I just make it a bit clean and just put a backslash. Now we can see the data display. I'm going to display data player, df player, and just the first 3 rows. Now just review. The format is CSV, option is header, option infer schema is true, and this is the path that based on this configuration, Databricks is going to pull the data for us. Just run it and let's see. Okay, we could load the data and exactly based on what we saw in the GitHub. Wonderful. But this is just for player. We need to copy all these steps, get a new code, and we need to do the same process for matches. I need to call the matches. Everything is the same, even the folder, but name of the file is matches.csv, and matches. Just see the first 3 rows, and I run it. And this is the match. We have the same column with the GitHub. Now everything is ready for doing cleaning and transformation process. Okay, now we want to apply some transformation steps. We want to apply 3 steps for transformation. First of all, I have to say for players dataset, we don't need any specific transformation. We have everything clean and neat. But for matches data, we have something and we want to use PySpark language to do this process. The first thing is we need to create date and time columns. For example, you see we have a column here, but in this column we have date and time all together. We want to split this column into 2 different columns. One of them is date and one of them is time. The next step is that we want to convert the format of the date to the date format. You see we have here, we have ABC. ABC means that this column is a string, but when we separate the date and time, we need to convert the format of the column date to the date format. In that case, when we convert the data to the date format, we can run better SQL queries later in the Synapse Analytics environment. And the last data cleaning step we want to do is about the stadium name, and we want to remove everything after the stadium name. For example, Ultra Ford is the stadium name for Manchester United team. We want to remove Manchester and these 2 soft brackets. We only need to keep the stadium name. Okay, we can start. First of all, let's work on this column. We want to split this column into 2 separate columns. I put the code that I ran it before, and I'm gonna explain it step by step. First of all, we need to import the library. We need the SQL function library for PySpark, and this function means split. Why we use SQL? Because before, you see, we put infer schema. Just because we have infer schema, we can take advantage of SQL and import the SQL libraries to PySpark. So we import a split function for PySpark SQL. Then for the matches data frame, we want to apply all these changes inside the data frame that we have it, and we don't need to create a new data frame. So we do all this process and apply inside the data frame. We call the data frame, and just because we need to add 2 more columns, we put with column. With column in PySpark means we want to add a column to the data frame. And we call the new column as a date. And based on this function, we want to split this column based on the dash. It means split the values for this column before and after, and just get item the 0, 1, the first one. And we have the same process for after or 1. 0 means before dash, and 1 means after dash. For after dash, just because we have the time, we put in a time column, and before, just we have date, we put date, and with bit column, we add 2 new columns. We store all this process in the data frame. And after that, just because we split this column, we don't need the original column, and just simply we can use drop function and drop this column. And finally, we see just the first 3 rows. Let's run the code and see the process. Okay, now we don't have any first column here. We don't have, just because we remove it. And if we go all the way to the right, we can see we have 2 more columns. One of them is date, that I just scroll up. You see, just because we split it, we just have date here, and we have the time here. We simply could split the date column into 2 separate columns. Okay, the next transformation process is about the date column. As you can see, data type is ABC, or you can see this is a string, but we need to convert the date format to the format of a date. For example, in the player database, dataset, you can see the birthday is a date, but even though we have date here, it's not date, it's a string. So we have to convert the format of a date. I add a new block of code and paste this piece of code here. Let's explain the code. Again, for PySpark SQL, I'm going to import 2 data frames, date format and toDate libraries. I say for data frame matches, I want to again add new column, and this column, I'm going to call it as a date, exactly just because we have a date exactly with this name. If I add a new column, the new column has the same name. If we add it, it is going to be replaced, and we don't have the new column because both of them have the same name. And we say, okay, the new column should be exactly this column, but the date format, we use toDate function, and the format, you can see, we have MMM, or the month's abbreviation of the name. Then we have dates to DD, and the full year 4Y. This is the format of this structure, and we say to PySpark, okay, consider this pattern as a date, they are not a string. And after that, just see the first 3 rows. If I run it, if I go all the way to the right, you can see we have the different structure. And now this is a date. We map it to 10th of August 2018. And this is again the same date, but it's not the date. It is a string, but now this is a date. And this column can be helpful for us for SQL queries later. And the last step is create the stadium name. We want to remove the soft bracket and the name of the team inside the bracket. I add a new block and paste the code. Again, from this library, I'm going to import the reg expression or regular expression replace library. We say, okay, for this data frame, just put it here. For this data frame, add a new column with the stadium name, just because they have the same name. If you don't have a new column, it should be replaced. And with this function, regular expression, remove everything. It means everything after the parentheses. It means start with parentheses. If you find anything inside the parentheses, it might be a letter, number, or symbol, a special character, everything inside the parentheses, replace it with nothing or remove it. And this code, see these columns, if see any parentheses, like this pattern, inside it, and the parentheses, all of them converted to nothing. If I run this piece of code all the way to the right, you can see now we just have Ultra 4 and we don't have Manchester. And James Park, we just have James Park and Vitality Stadium, and we don't have the name of the team. Now we did all the transformation steps. Now it's time to push the data from Databricks to the data lake. Okay, before pushing the data to the data lake, let's see the current status of the data lake. If I go to the storage right now, if I go to the container, transform data, nothing is here. We want to push all the data from the Databricks, the transformed data frame, here. But what we did so far? We grabbed the raw data, we did any data pre-processing that we needed, and we want to set or push the data into the transformed data. Okay, I need this piece of code. This piece of code means, first of all, which data frame we want to push. First of all, let's go for data frame players. I want to write, or I want to set or push this data to a place, but which format I want to save it. I got the CSV, but I don't want to store CSV file. It is better for Synapse Analytics to store Parquet file. Parquet file is the best version for columnar data or some structured data. We can use CSV, but it is better to use Parquet file. Parquet file is the better version for columnar format. I put Parquet as the version. The mode is append. It means we want to add a new data to that folder. And the option is path. We want to give the location for the transformed column. First of all, what is the name of the data lake? The name of the data lake, it is exactly that location. I only need to copy name of the data lake that we have it. I grab it and paste it here. What is name of the folder that we needed? It is transform. And in which folder inside the transform folder we want to save it? I want to save inside the transformed players. And I don't need it. Oops. Yes. It means just because we have the data lake storage inside the transformed folder, I'm going to create another folder as a transformed player. And inside it, I'm going to save a file as the df player with the Parquet format. Now I need to do the same process for matches. And matches. And everything is the same except the last one, matches. And just double check Parquet file, append, data lake, the folder, and that's it. Now just double check the name of the folder because it is very important. Okay, here I can copy to make sure it is exactly the name that we have it. Now I just paste it, that's okay, just for making sure, and we can run it. Let's run and wait. That's okay, everything is okay. Now we can go to the data lake to see whether the Parquet file, the transform data, are there or not. Okay, now we are in the data lake. Just refresh, go to the transform. We have two folders that Databricks made for us. One of them is for player. We have several files, but this is the Parquet file. If I click the right, you can see this is the Parquet file. This is the player's transform data. And if I come back, this is the matches file. This is the match cleaned data, and the format is Parquet file. If I download it, it's a Parquet file. We cannot do anything in the Windows or even in the Mac, but in the Synapse Analytics, we are going to get many insights with SQL queries from this data. Okay, now we came back to the Azure and we want to create another service which is called Synapse Analytics. I can go to the Synapse Analytics here, or I can just search it. I go to the Synapse Analytics, go to the create, and create a new environment. My subscription is Azure subscription. The resource group, we have many resource group, and even this group, we made it for Databricks, but I'm gonna choose England Soccer resource group. This is the main resource group. The manage workspace, we can say England Soccer Football manage resource group. This is for, let's say instead Synapse. I just want to have the same structure with the Databricks, but this time I put Synapse. The workspace name, it is the name of the workspace. We can say England Soccer just Synapse. Workspace should contain lowercase, that's okay. Just a soccer and England. And okay, that's okay. The region is East US account name. Just because we want to use data lake in the Synapse Analytics, we don't need to create a new account. If you want, you can create a new one, but I select the data lake that I have it, and which folder inside the data lake I'm going to use it for Synapse Analytics. Definitely it's not raw data. We use raw data in Databricks, but in the Synapse we want to use transform data, which we use PySpark to transform the data. So inside the data lake I'm gonna use transformed folder. I go to the next step. Here I should create the SQL server name. I'm gonna say admin Mehrdad. And the password, I'm gonna say just, you can write down your password. Oh, they are not matched. Wonderful. Okay, yes. and everything is okay. We don't need it. Go to the networking. I think everything is okay. Hello, connection for IP address, that's okay. This is the tag, and just review and just create it. $5, and this is admin Mehrdad, local, and that's okay, just create it. Now we are building Synapse environment. We just need to wait like other Azure services. Okay, now Synapse is ready. We can go to the resource group. In the resource group, we have Synapse here. We can simply click on Synapse. Again, like ADF or Data Factory or Databricks, it has its own studio. I only need to go to the open and we jump to the Azure Synapse Analytics environment. Okay, name of the studio is England Soccer Synapse, that we made it before. It looks like Data Factory. Data Factory has some more features. However, all those features, not all of them, most of them are here. And they have the same process. Exactly, we can make some pipeline, exactly what we did it for the Data Factory with integration tools, anything. But I mainly use Synapse for analysis, not for making the pipeline. I use Data Factory for pushing and pulling the data, and Synapse Analytics just for running some queries, and even here we can write some PySpark. Here, if I use PySpark, I use just for analysis. Or if I use SQL queries, just answer the business questions, get insight about the data. But I use PySpark in Databricks for data cleaning process, or machine learning models, or even in Azure's environment, later you can see, we use Azure ML Studio for machine learning. Now, what is the first thing? As you know, we have transformed data into the data lake. But here we have to again pull those data in this environment. How we can do that? First of all, I should go to the data here, and I need to create a new database. I have two Parquet files. One of them is players, one of them is matches. And they are just in a data lake. They are Parquet file. And how Synapse can analyze Parquet file? We need to store Parquet file into the database. It is the magic of the Synapse. It means without having the real database, we can behave with CSV file, Parquet file, any kind of file as the database. We can run some SQL queries even in the Parquet file. And we don't need to create any real database. That's the wonderful things about the Synapse. I created database, and this database is a serverless. It means I'm not going to create any database in Azure database or even in SSMS. It's not just a real database. I'm going to mimic the database process for that Parquet files. So I use serverless, and I call this database as England Soccer. Let's see, England Soccer database. It is my database, and I'm gonna create it. Oh, it seems it doesn't accept that naming. Let's see, England Soccer database, and just create it. Okay, now we have one database, and this database is here, but nothing inside it. We have just external tables, folder, external resources. We have some default view, and we have default schema, and some security things. But where is the data? Where is the Parquet file? We need to import those Parquet files inside the database. Okay, for importing the data, I go to the develop and I'm gonna create a new SQL. If I use notebook, it means I'm gonna run PySpark or Python code, but I'm gonna write SQL queries. It is the goal of this project. We want to do all this process to come to this step to run some SQL queries. But before SQL queries, we need to have the database. We have the database, but no table in there. We need to import the table. So I open the SQL queries. Okay. I call this name as the schema and for the view. Okay, first of all, let's call this name as a schema. Okay, a schema in database means we should make the environment or the schema and put database inside the schema and put that schema inside the databases and then map those tables to the schema. Just because we just have Parquet file, we don't have any schema. And even in the Databricks, we use infer schema, if you remember the Databricks section. Okay, I should create the schema. I say create. It is exactly the SQL queries, any SQL database management studio that you are using, MySQL, SQL Server, anything. It is just a SQL code, but this is TSQL or Microsoft SQL queries. But before we do anything, we should change the database. We need to map, not master, the England Cycle databases that we made it. Now inside this database, I'm gonna create the schema. I say create a schema, and I'm gonna call this schema as a England Cycle. This is my schema, and I let's do here, just name it as a create schema. Okay, now inside this schema, I should make two tables for this schema. For adding the table inside the schema, specifically if the data is Parquet file, we use open row set function. Open row set function can bring all the Parquet file to the Synapse SQL and convert it to the SQL table. Okay, I say select everything from, and I have to say open row sets, open close parentheses. The first table that I'm gonna bring, just let's call this piece of code as a create view table for players. We are gonna bring the players. It is the bulk, inside the bulk, and after that the format. The format of the file is just Parquet file. The Parquet is the file that we are gonna bring it. But what about the bulk? Bulk is the path or location of the players' transform data that are stored. Now we have to come back to the data lake and bring this link. Now I'm here, I go to the storage, go to the container, transform. We are gonna bring the players. I go to the players, Parquet file. This is the location. I just need to copy and come back to the Synapse. Now I'm in a Synapse. The only thing is that I need to copy the location here. But just because the data lake storage and the Synapse Analytics, all of them are in the same Azure environment, I don't need all this data from here. Just transformed player. Inside this folder, we have the Parquet file, and the Synapse understand I'm mentioning that specific file. Create view, and I'm gonna just call it the players as all this process is a view, and that's it. I'm gonna call as the players, but I'm gonna call should be the schema. In this schema, I'm gonna create a new table which is called players, and this player is coming from this path. Okay, and again I need to do the same process for another one, which is for matches, and this is matches. I need to copy here, and we need to just bring the location for matches, come back to the data lake, and inside the data lake I go to the transformed and matches Parquet file, copy the location, and come back to the Synapse. Now in Synapse I only need to paste it and remove all the way to the folder. That's it. Just review the process. First of all, we are gonna make the schema, and then inside the schema we create two views. One of them is for players, one of them is for matches. Players is stored in this path, and this is stored in this path. Okay, the last thing, we don't have a blob, we have the data lake. So we need to change the blob. We need to put DFS. DFS means data lake, and DFS. Okay, this is the only change that we applied for the lake. Okay, now everything is ready, and we need to just run it. Okay, we have the syntax error. Let's see the error. Okay, first of all, let's create the schema. Let's run it. The schema is there, and now we can create a new SQL queries. Paste it here. Create view as select format. We can create one by one even. I cut it and just run it. Oh, which is the master, it should be that's England, that's okay. Just run it. Okay, this is the first one. Create the new SQL, and this is for matches. Again, go to the England, and this is for matches, and run it. Now we can publish all these steps. Schema, script 1, script 2, just publish. Okay, publish is completed. We can go, only need to right click on here and just refresh the database that we made it. Go to the schema. You can see England soccer schema is here. Exactly the schema that we made it here. And if I go to the view, we can see these two tables. Now if I close it, if I close everything, just close a new, go to develop, just create a new SQL, and just go there. We have all the columns for matches. For example, I want to see select everything. It is just a SQL queries for England soccer matches, and the database is this database, and run it. This is all the data, all the columns, all the rows, And even there is a chart, but this chart is meaningless because we don't have any meaningful query. It is just select everything. Now we are going to run SQL queries and answer questions. And this is the final goal for the project. Okay, now it's time to answer some questions. In Synapse environment, I just open this menu and go to the data. The database that we created, the serverless database, is here. If we go to the view, we can see two tables. One of them is for matches with this column. I just open a bit. And the other one is player with its own columns. Now it's time to create SQL node and run some SQL queries. I go to the develop and create a new SQL script. Let's run it queries, or let's say question 1. Question 1. Okay, what is the question 1? Question 1 is saying, what is the average attendance for games or matches where the total goal count was higher than average total goal count across all the matches? Okay, this question is saying we should go to the database and just focus on the matches table. The first thing is that I should use the database as an England soccer database, not the master database. Okay, first of all, I'm going to mention which columns we needed. We need attendance, this column, and we need total goal count. If I scroll down, we can see total goal count is here. First of all, let's select both of them. I select attendance, and the other one is total goal count. Total goal count. I just put both of them underneath to have better view. Both of them are coming from this database, England soccer matches. Now, if I run this query, we only see these two columns. We have the attendance and we have total goal count. But we need just one number, average attendance. We don't need any table. We need the average attendance for all these rows, only for those rows that the total goal count is more than average of total goal count. So first of all, let's see what is the total goal count average. If I go there, if I just copy everything, I need to remove attendance and just put average for total goal count. Let's see what is average for total goal count. The average is 2. So it means if I run this query, I only need to focus on the rows that the total goal count is more than 2. I can write like this way, where total goal count is more than 2, but it's not professional way. Instead of the 2, we can use subqueries. So instead of these 2, I put the parentheses, and inside the parentheses, I just need to that one. That's it. And this is the subquery. And if I run this piece of code, now we don't have any rows that total goal count is more than 2. Okay, but as I said, we are looking for just average attendance. So I say average, and I don't need this column. That's it. We just need to have average attendance. And now I run this query, and this is the answer of the question. The average attendance for matches where the total goal count was higher than average total goal count is 38,923. Now, second question. The second question is asking which referee officiated or appeared the most matches and what is the average total number of fouls committed in these matches. Okay, we need some columns, and first we want to grab those columns. I go there and I select the only table that we needed. It is the matched table. We need a referee. I select referee. We need a total number of the fouls, but we have for fouls, we have total goal count, but for fouls we have home and away. So we should put both of them. First go for home team fouls and away team fouls, and that's it. These columns that we needed, and go for from which database, England matches. This is the columns that we needed. I just run it. Okay, we have name of the referee. We have home team, number of the fouls for the home team, any team that it can be, and away team fouls. Okay, now we should do something. First of all, we should find how many matches the referee officiated. For doing that one, I need to add one more column as an aggregation column. Count number of the rows or count everything. And then just because we put an aggregation column, we should add the group by based on the referee. We want to group all the referee based on the number of the matches they officiated. But what about these two? If I run it, absolutely I get error because I didn't put underneath the group by, and I don't want it because a question is not asking the home team goal or away team goal. It is asking total number of the four. So instead of having both of them, I can say make the average, one more aggregation column, and I say make the average between the total home team fouls plus away team fouls. And in this case, we don't need to put both of them underneath the group by because right now, both of them are in aggregation and I need to add one comma. Now, if I run this piece of code, we have the referee. Okay, we have to add aliens. I can say this one is number of matches. And for that one, I say, we should put there, not here, number of the matches, and we should say total false. And now let's run it. We have referee, number of the matches, and total false, and even we can make a space between them. Okay, what is the next step? The next step is asking which referee. I mean, for example, top 5, top 10. Let's have top 5. Okay, if I want to have a top 5, I would say that one is better. I don't like a space in the queries. I should sort the data. So I have to say order by. I'm going to order all these columns based on a number of the matches because the question is asking most matches. Number of the matches. The data should sort based on a number of the matches, and the method should be descending. The toppest means the most appearance. And if I run it again, we can see Anthony Taylor, which is very famous, just appeared 32 matches in the whole season. That is pretty high number. If I scroll down, we can see just Andy Madley appeared just 2. Maybe he didn't perform very well during the matches. But even just these 2 matches The average total fall was 16, but for Anthony Taylor was 21 among these numbers. It means Anthony Taylor might behave very softly compared to the Andy. Okay, we need to just keep the top 5. So I go there and I say select top 5. That's it. And now we run it. Okay, we keep this one. These are the referee that appeared in the most matches, and this is the average. However, this is the average. Average total false. I run it again, and we can even see the chart. This is the magic of the Synapse. We didn't create any database. We just created a serverless database. We are working with a Parquet file that came from the GitHub. It was CSV file. And in the CSV file, we are running SQL queries. If I go to the chart, I can say, just because this is a categorical variable, I'm going to use bar plot. For the category column, definitely I should put the referee. And I want to put the number of the false, and the legend is just the false, average false, and for the category label, I put the referee. And this is the picture, and even you can save this picture or pass it to anybody else that you need it. This is wonderful. And that's why I love Synapse Analytics in Azure environments. Okay, now question number 3. Question number 3 is saying, for each player position, calculate the average goals scored and assists made. Which position has the highest goal to assist ratio? So it means we should work with the player dataset. Instead of the matches, I go for England soccer player table. Let's call which columns we need first. We need a position, definitely. We need goals, how many goals that player did, and how many assists. All of them comes from England soccer player. Let's run this query to see the result. We have position, defender, modifier, goalkeeper, and it makes sense. Goalkeeper, it's very rare that goalkeeper scores a goal. Okay, and we need to calculate the average goals and assists. So instead of the position, instead of the goal, I have to say average for goals, and average for assists. I call as average assist, and I put the alias average goal. And just because we used an aggregation function, we should group data based on the position. Exactly, this is something that question is asking. If I run it, you see goalkeeper based on an average, didn't score any goal, didn't assist in any goal. Modifier and forward, that makes sense because they're forward, they might probably score much more than other positions. Now we need to create a new column, which is the ratio. The ratio is goal divided by assist. For example, we want to add a new column here, and we want to divide 0 by 0, 1 to 1, and anything. So I create a new column as the average goal should be divided by average assists. And I'm going to call it as a ratio. And just this one. Now, if I run this piece of code, let's see what we get. We get nothing. You know why? Because we have some 0 as an assist, and 0 doesn't make sense in the denominator. So instead of having the goal assist, I'm gonna first put the comma here. I'm gonna cut it, this section. And I said null if, open close parentheses, null if the average assistant put 0. And now if I run this piece of code, you can see the average for some of them are null. That makes sense because 0 divided by 0 doesn't make sense for SQL, and we put null. So the last step is just we need to sort it because we need to have the highest one. Order by. We need to order based on the ratio. And the process method should be descending. Now this is the result of the question. Forward and then modifier. That is the answer for this question, or even we can go to the chart and make a pie chart. The category column, let's say position, and let's say the ratio. You can see the forward has the highest ratio, and then we have modifier, and goalkeeper and defender, definitely nothing. This is question number 3, and we can go to the next question. Question number 4. Compare the average goal scored, corner counts, and position percentage for home teams versus away teams. It means we should make a table, and in the row, we should put the home, and in the second row, we should put away. For the columns, just because we need to compare, we should have average goal scored, average corner count, and average position percentage. In that case, we can compare them. Let's start. First of all, I'm gonna select. First of all, we need to work on a matches table because all these columns are into matches. I need to select what I need. I need the goal scored. Select home total goal, and I need the average. So I put the average home team total count as, let's say, goal. For all average goal. This is the first one. The second one, we need to copy. We need to have the corner count. I think it is the home corner count. And the third one is position. And home team position. This is the average corner and average position. Okay? All of these columns come from England soccer for matches. Okay, if I run it, it is meaningless because we don't have anything. We just have the average goal, average corner, average goal, average corner, and average position. Oops. And this is just for home. But what about the away team? Okay, we need to copy these ones and paste it here. But if I run this query, we see just the last one. Because the SQL or even other languages like Python just read the last query. If we need to merge these queries, we need to write union. And now if I run it, we can see all the results. Now you see we have all together. Why? Because they have the same columns. We have average goal, average corner, average position, average goal, average corner, average position. But we don't need it. We need to separate based on a column. So we should make a column. Then that column should differentiate between these two rows. And after that, just because the SQL cannot concatenate those columns with each other because they have this different naming, so in this case, we will have two rows. I select for this one and that one, I just select one string. For this one, I say home, and I say as, for example, team type, and that's it. And for that one, I put away. This is a new column. In the first row, I put home. In the second row, I put away. Now, if I run it, we have two rows. We have home and we have away. The average goal for home and away is the same, and everything is the same for these ones. Why? Because we got wrong. For this one, we should put away. And in that case, we can see the results. Away, and just run it. Okay, for average goal, they have the same, but for average corner, it means the teams where home or where hosting, they have more average corner and even average position. These are the results, and if you like the previous questions, you can define and make some charts. Okay, question number 5. Which team had the highest shoot accuracy? Shoots on targets to total shoots. It is the shoot accuracy across all the matches. Again, we need to go to the table for the matches. First, let's see which columns we need. We need to select, first of all, the team name, home team name. We need the shoots on target. Where is the shoot? Shoot, let's type it. Okay, we have the home team shoots, and we have shoots on target from England matches. Let's see these. Oh, we don't need it. And run it. We have name of the team for every single matches. It means we might have some duplicate because we didn't group any data. We have home team shoots and home team shoots on target. So, okay, now we need to create the accuracy. The accuracy is calculated, the total shoots on target divided by total shoots. But if I run this code, I might get error. Why? Because there might be some teams or some matches in this list that they didn't have any shoots. If I scroll down, we can see just, or even we can sort it. Let me just put it this way and just say order by, for example, number of the shoots and ascending. If I run this piece of query, okay, for example, Bournemouth and Cardiff in a game, they couldn't make any shoots, let alone shoots on a target. So we have to say, okay, if I want to have this accuracy, I should put a condition where the total number of the shoots should be greater than 0. In that case, we don't have any denominator as a 0. Okay, now we have total number of the shoots, everything. Let's call this one as accuracy, and let's run it. We have one more column as the accuracy. It's not the way that we need it. We want to have the summation. For example, I have to say the sum of the home shoots on target divided by sum for home total shoots. And just because we have aggregation function, we have to group by, and it should be I can remove these two. We just need the home team name, and home team name should come here. We say home team name and summation of total shoot on target divided by total shoots, which is called accuracy, from this table where the total shoot is greater than 0, and group by based on a home team. If I run, okay, why we still get 0? Because we divided without put any percentage. We should go there and let's say multiple by 1. If I call it, that's the accuracy percentage. We have Bournemouth, the accuracy is this number, and this is all the teams. These are just the home team. What about the away team? So I copy all of these ones, paste it here, and just change it as away. I copy the away and paste instead of the home. And that's it. And just because we have one column that make it differentiate, that is away team and home team, we don't need to add the string column like we did in the previous questions. And between these two, I put union. And let's run this query. Now we unions, and now we have the accuracy for the teams, regardless they are away or they are home. Good job. In this project, we steps all this journey. We grab the raw data from the GitHub. We use Azure Data Factory to pull the data from the GitHub and push it to the data lake. After that, we use Databricks PySpark to do some transformation and clean up the process on the data. Then we push the data and push it back to the data lake. After that, and final step, we use Azure Synapse Analytics to run some queries and get insights about this data. Please stay tuned with me. I will upload many projects about Azure environment, end-to-end projects. In this project, we run SQL queries. In the next project, we do this process or use different services, and instead of SQL, we use PySpark or Python language in the Azure environment. Or in the next project, we are going to work on machine learning and see how we can use Azure Universe to run, build, and deploy machine learning models. Thanks for your watching, and see you later.